In this worksheet, we're going to see how to calculate concentrations of solutions. Why do we need to do this? Well, many reactions take place in solution. Solution provides an environment for two reactants to come into intimate contact with each other so that they can react. These same ingredients probably wouldn't react if you just mixed them dry together. It's only when you get them into solution that they can come into contact and react. In order to understand how much product we're going to get in a chemical reaction, which is a big concern with the end of chapter 6, in order to understand how to calculate that for a reaction in solution, we're going to need concept of concentration. Now, you instinctively know what a concentration is already. If you drink coffee, say, you like your coffee probably a certain way. You might like 2 teaspoons of sugar for every mug. One mug full of coffee, okay? Now that's a concentration because it's telling you the amount of something that's dissolved in a mug full of coffee. We can define a concentration in general as an amount of solute. Solute is the stuff that we dissolve in the solution. That is the sugar in this case, divided by some amount of solution. What's a solution? Solution is a homogeneous mixture. We talked about those way back in chapter 1. Of the solute, the sugar, and the solvent. I guess you'd call the solvent in coffee the water because it is the component that is present in the largest amount. But in this case, coffee has other things in it besides water. So the solvent is water and all the other stuff. There's this one solute that is standing out. So it's a homogeneous mixture of this. And this word homogeneous is kind of important in understanding how to make solutions. If you just dump your 2 teaspoons of sugar into the bottom of the cup and then put coffee on top and it's not mixed, you don't have the same concentration of sugar all the way through the cup. You've got to stir this pretty well. So when you talk about concentrations, you're talking about, if you're talking about solutions, you're talking about something that is well mixed, that is evenly mixed, so that the concentration is the same at every point. And it can happen in real life that the concentration isn't the same at every point if you don't mix well. And this will be crucial in us making solutions in a little while. Now, suppose you've got a roommate and they like their coffee like this. They like 4 teaspoons of sugar for every 1 mug. So here I have 2 in a mug. Before I mixed it, it would look like that. And here I've got 4 of them down there in a mug. So there's a lot more sugar. You can see pretty easily that the concentration here is twice what the concentration here is. If you double the amount of solute, that doubles the concentration. Now, another effect is what happens when you change the volume. So suppose I get another mug, and instead of putting a whole mug full, I have half a mug full. And I put 2 teaspoons of sugar into a half a mug of coffee. What's the concentration going to be? Now, compare it to this. If you take half a mugful with the same amount of sugar dissolved in it, the concentration is going to be double. Here the concentration is 2 divided by 1 teaspoons per mug. I mean, you can write this as 2 teaspoons per mug, like that. And you can write this one as what? 2 divided by a half is what? So you've just made your roommate's coffee here. It has the same concentration as your roommate's coffee. So if you double the volume, if I go from here to here, I'm doubling the volume. That halves the concentration. If I go from this one, 4 teaspoons per mug, to this one, 2 teaspoons per mug, I'm halving the concentration by doubling the volume. You can see that in a picture like this too. Here's another way to look at this fact here. Suppose I've got a box here, and it's a solution, and it's got some molecules of that stuff in there. I can say the concentration is the amount of solute, which maybe is 6 molecules. And maybe this box is a 1 liter box. So I can say my concentration there is 6 molecules per liter. Now suppose I put an identical box next to that, another liter, and I take this divider out. What happens? I now have a 2 liter box, and those 6 molecules will move around in there. They'll not all stay piled up in one place. Because molecules are in continuous motion, they will travel all over the inside of the container, into every space that's accessible to them. But you still have 6 molecules in there. We didn't take any molecules in and put them out. Now what happened to the concentration? Here the concentration is 6 molecules per liter, and here it's 3 molecules per liter. So if I doubled the volume here, I half the concentration. Now if you understand this, if you can visualize this, you're going to be able to see whether or not the calculations that we do in this worksheet make sense in the end. And in the next worksheet, we'll talk about actually doing some math